Hey, what's going on, folks? It's Mike here, and welcome to the next lesson in the D programming language series. In this lesson, we're going to be talking about a cool feature of the D programming language known as scope. Now, scope statements allow us to get deterministic action within our code. So what do I mean by that? Well, we've already seen one example of that if you've been following along with this series, meaning that when we've looked at structs, for instance, if we have a stack allocated struct, we can specify a constructor and a destructor that'll be called when it moves out of scope. So with that said, let's go ahead and just look at a little bit of a code example, and then we'll revisit the scope statement and see how that works in the D programming language. So let's go ahead and dive straight into the code today, and then we'll go ahead into the documentation. But let's set up a little main file here and just review some of the things that we've been doing here. So if I have just some struct s like this, and let's go ahead and create some function like this. And what we're going to go ahead and do is create our constructor. And let's go ahead and create a destructor here, like this. Okay, so this is our destructor and our constructor. And let's go ahead and give ourselves a little bit of room here. And in our constructor, let's just go ahead and write out some message here. S created. And then let's go ahead and have S destroyed. Now we will need our library here for, let's go ahead and import standard IO. And let's go ahead and create an example of our struct here, something like S here. Okay. And let's go ahead and give this program a run here. Okay. Now, I am getting an error here because we have to remember with our structs, well, we get these for free here. So I need to either pass in some parameter or either disable the actual struct here as it's recommended here with disable here. So let's just pass in a parameter here, string s, and we'll pass it in here. And let's go ahead and create our structure here. Hello. And let's go ahead and do something like that. Okay, just so we can demonstrate creating our struct here. So what I've got here is, oops, one more error here at line 17 here. And the decompiler is always trying to help us out here. But what I've got here again is, well, my code is automatically called with my constructor. This is the first thing that happens when I am setting up this object here, S. And then when I leave scope here, you can see that this destructor is automatically called for us. Okay, so I've allocated this struct on the stack here, and then when I leave scope here, we just go ahead and clean things up. Okay, so this is a nice sort of pattern. And folks coming from a C++ background are going to be used to this RAII pattern here. Resource acquisition is initialization. And it's arguably one of the most important features of the C++ programming language, and we have that available to us in D in a few different ways. So we have that in structs, where we can go ahead and write a destructor. We can also do this in classes, which we've got to talk about classes later on here. But in the D programming language, there's actually another sort of paradigm or something that we use here. So I'm going to go ahead and open it in two different places here in Learn. And then if we go to the documentation, the language reference, and then let's go to statements here, statements. And we'll go ahead and find the scope statement. Where is it here? We're going to have to just search for it here. Scope statements. In the first statement here, or we want scope, and then, yeah, something like exit here. So scope guards is specifically the feature we want here. So what is a scope guard? Well, let's actually go up here to section 21 here, just so you see how to get to that. With our scope guards, scope guard statement. Oops, sorry, I just want to get this on the center of the screen. We have ways to define what happens when we actually exit, or when some scope is left here. Okay, so what do I mean by this? And the two different ways I could show you, there's a great example on the D tour here under D gems and scope guards. We can see some other examples. Is you have scope exit, which will always call some set of statements. So even if you have some exception or some weird behavior, scope success, which is called when no exceptions have been thrown. And then scope failure denotes statements that will be called when an exception has been thrown before the block's end. Okay. Now, usually most of the time I'm using something like scope exit because I want to make sure something always happens. And that was sort of the thing with C++, where we always want this destructor to be happening here when something gets destroyed, okay? And that includes when there's like exceptions and so on. But what if I just have some code? What if I'm just interfacing with some C library that doesn't have destructors, okay? Well, the good news is we have scopes. And this is going to be similar to other languages if you've seen defer, for instance, in Go or V or some of these other languages. But let's go ahead and do an example here. And the easiest way to demonstrate this is if I go ahead and do a write line here, and I'll actually be using this. Let's go ahead and just put it at the global scope here. Import, and I'm going to shrink this down a little bit because I think we're familiar with our structs. But let's go ahead and, for instance, do a scope exit. And then you can put it in the left and right curly braces if you want, or you don't have to if it's just a one-liner here. So let's just do it as a one-liner here. I'm going to go ahead and write line here, and I'll say world. And let's go ahead and put this here. And let's see what happens here. Now, normally, if you're reading, again, this program just top to bottom, if you only see the write line portion, you'd expect that to be printed out here. But again, scope means this is going to execute just like with our destructor here and show us at line 19, well, whatever code we want to execute here. Okay, so let's go ahead and run this. I'll bump this up just a little bit for you. Now, if I run it, again, we get our S created, hello, S is destroyed, and then our world is then pushed onto a stack, literally, and it's called here, okay? So that is our scope here. And let's actually try this out if I do hello here, okay? So what if I have two things that are scoped here? I go ahead and run this. Well, I get hello world here. Okay, and here's the idea here. I'll illustrate it. That with all of our scope statements, and again, typically I'm using scope exit, but again, it's put into a stack here where we have the block of code that is here. And you can effectively think of this as just like rewriting the code, but it's sort of pushed into a stack where we want to write out world. And then we get another one of these. So we put it into like a stack data structure. Hello. And then in my actual code here, which again, when I hit the very end here, which is at line 18, then I start executing hello, complete that, and then I start executing world. Okay, so that's the idea. Now, of course, there's a couple ways that we could structure this, and I could, let's see, let's go ahead and let's delete this here. Let's go ahead and just reorganize this so I use it in the brackets, and I could write out hello as follows, and also world here. Okay, so I could also just do that. You could use the, if you've got some more code that you want to call here, that's no problem here. And you'll get the same behavior here. And this executes one line after the other. Now, again, some pragmatic use cases where you might use scope exit, for instance. And why I sort of like it is, let's go ahead and say you're using something like malloc, which we haven't looked at yet here. So I've got to actually open it up in the standard library for you. Here, let's just open this up in Dlang. Let's go to our library, and I'm going to go ahead and just search for malloc. And let's go ahead and see, where do we have malloc here? Should be in the core standard library here. Let's find an example of malloc. And for those that don't know, this is a way to manually allocate memory, right? So here's our actual function here. Actually, the really important thing that I need is just this for the import. So import core, our standard C libraries, and then they're usually the same name as the C library. And then what I'm actually going to do here is say, let's get some memory here. I'm going to cast these to unsigned bytes, call the malloc function, and I want, 1,000 bytes here, or 512, some, nice power of 2 here. Now, let's go ahead and say that I run this program here. Let's first make sure that it runs here. Oops, I need a equal sign here, going a little bit too fast here. There we are. Let's go ahead and give this a run. Okay, so this runs fine here, but there is a little bit of an issue here because I'm manually allocating our memory. So if I'm manually doing some task like this, like allocating memory, I need to make sure that I reclaim it, okay? So there's two options here. And this is usually what happens in programs, right? We come down here and maybe we do like a for each, or, you know, in this case for int I less than 512, you know, maybe we write out every single byte of memory. Okay, let's actually just do that here. Memory at I. Okay, just as an example. Oops. Okay, cannot use this operator on expression of type ubyte. Ah, that's because I made a mistake here. Some of you have caught, and that's why it's always nice to kind of push these examples a little bit further. This is a pointer here. Now we can address this. And we get lucky, it happens to be zeros in here. But again, when we're manually allocating our memory, we don't necessarily have a guarantee that's going to be 0 initialized here. But again, we're using this memory here. And then as a programmer, I, you know, just have to remember, okay, after we're done with this, and let's pretend we do, you know, 1,000 more lines of code or whatever here. Maybe we have a really big function or whatever. And then I need to free the memory. Okay. So there we go here. So now when I run this, this is correct in the sense that it's not leaking memory. But, you know, you never know what happens in these programs. So maybe some other engineer comes in here and they have some, you know, if case here. I'm just going to put if false. So this never comes in and they say, oh yeah, I definitely need to make sure I, you know, free that memory here. And then we have this other branch here where I'm going to go ahead and say else, you know, do something else. Well, what have I done now? Well, now I have, again, created that memory leak, right? Because this branch is never going to execute. I look at this and I say, well, I'm allocating memory. Oh, yeah, I have a matching free with the malloc, just like I learned. But again, that could be problematic. So I run it, it compiles, and then I just never discover this memory leak that occurs. So the better paradigm here of what we can do is let's say, well, I know I definitely need to free this memory. I know its scope is going to be this block. So I can just go scope, exit here, and then, you know, free my memory or do any, you know, cleanup that I need to do here. Okay, so we could go ahead and write it out like this here. Okay, and of course, because I'm able to put multiple lines here, I can do a little bit more power. I might want to say if memory, right, make sure that we allocate it or whatever, then we free it, right? So if this isn't null. So anyways, these are a few of the different patterns that you can use here. Now, the other one that folks often think about is with like files, for instance. If you open a file, you need to make sure that you close a file. Now in D, I think it's a little bit smarter in the standard library. Let's actually go to our standard IO library here. And if I find a file, let's see if I find the struct here. Oops, I think I gotta find it at the top here. Let's see. Here's file. Oops, I guess it's aliased here. Oh, this is a part of the core C library here. Okay, so I gotta be a little bit careful here. Let me make sure I find the right thing. Right, because we have C libraries, and then we have our standard IO in D here. Let me make sure I clicked on the right one. Let's close that here. Go here. Okay, almost made a mistake. All right, just trying to get to the right standard IO. There we are. Well, we have this file here. So, you know, this file here is effectively a struct here. But the file type itself that's been implemented, it automatically does the file closing, right? So I think they've implemented this with a struct or something. So we don't have to remember to close files, but if you wanted to, I wouldn't blame you if you're a little bit paranoid about it, or if you end up using the C standard library version. That would be fine here. But that's just also something to keep in mind. That's another common example, right? That you learn that when you open a file, you need to make sure you close it so that you close that file handle. And there might be other examples like this, right? Let's think about, and I'm actually just staring one, you know, with locking. Let's see if we have lock here. This is going to be for file locking. So I don't exactly want to do this. But in your standard library, let's go ahead and see. Let's find our mutexes. This would be another example. Right, for our mutex where we want to lock and unlock it. I wonder if they actually... Yeah, so if I did like a lock here, and then I want to make sure that I do an unlock here. I wonder if they use scope in any of their examples. No, they're just showing off the lock and then unlock. So again, these might be some places where scope is a really, really nice feature here. Now, the word scope gets used in some other contexts, which I'll talk about in like functions, but these are scope guard statements. So let's go ahead and put it in here. Scope guard statements, which I think are a really nice feature of D. And again, you have the ability to say only if there's a failure to call this. So again, if you're catching some exception, or only if there is a success here, okay? And if you're not sure when it's going to be called here, again, I tend to use just scope exit, right? As you're learning this, just, give yourself a little bit of a write line here. We'll run it, and then again, we can see that we're comfortable. Yes, this is running and clearing our memory, okay? If you want to check this for memory leaks, you could run this through Valgrind or something like that. All right, so with that said, folks, I hope you enjoyed this lesson. As always, you can find these lessons on my website. If you want to track your progress in the deprogramming lessons here that we've been doing, you can sign up for free and just track your progress there and go ahead and enjoy that. And yeah, let me know if you have other clever use cases for scope guard statements. I think they're really useful. I like seeing these types of things like the fur and so on that help make us better programmers and kind of localize the complexity there. So I can see when I'm opening something and that I am freeing a resource without having to forget that. I think it's a really nice paradigm. All right, folks. Anyways, with that said, I'll look forward to seeing you in the next video.